right, let's go ahead and look at how we distinguish the difference among the different sampling methods. So the goal of sampling is to obtain a representative sample. Representative sample, because the statistic being obtained from the sample is a good estimator of the corresponding population parameter. Some sampling methods can result in biased samples that may not be representative of the population and can produce statistics that lead to inaccurate conclusions about the corresponding population parameters. So anytime we take surveys, right, when you guys think about surveys, you see statistics. We need to identify the best sampling method to use in that case because we want to avoid any bias that could occur from our sample. Now, the different sampling methods we have are a simple random sample, okay, where each individual in the population has an equal chance of being selected, okay. A self-selected sample, which is our second one here, our self-selected sample is when individuals volunteer. Okay, and it kind of gives it off by the name self-selected. You volunteer yourself to be part of the sample. Third one, convenience sample, is when individuals are selected based on how accessible they are. Systematic sample, members of the sample are chosen according to a rule, such as every nth individual in the population. And then we have these two, stratified and cluster. Okay, when it comes to determining the difference between stratified and cluster samples, I think this is where most students tend to struggle because their definitions are very, very similar. So let's go ahead and take a look at these. A stratified sample says the population is divided into groups and individuals from each group are selected, typically through a random sample within each group. In a cluster sample, the population is divided into groups, and either all the individuals in the selected groups are selected or just some of the individuals from the selected groups are selected. Okay, we don't really need this line here. Not necessary. So, as you can see, very similar definitions. The population is divided into groups and individuals from each group are selected. Cluster sample, the population is divided into groups once again, and either all of the individuals in the selected groups are selected or just some of the individuals, which means that even though we do have groups, we can go without representing a specific group because they may or may not be chosen when it comes to cluster sampling, okay? Stratified sample, you will have an equal representation from each group. All right, now let's go back and look at our examples and determine where each of our examples in the Explore unit fall into the sampling method. So if we go back and look at our examples, okay, A says suppose the employees whose salaries volunteer. Well, if they volunteered themselves, what category do they fall into? Simple random, self-selected, convenient, systematic, stratified, or cluster? Now, the key phrase in this was volunteer, right? So we can classify this as being a self-selected sample. So this goes back to example A. Now, example B says suppose that the first six salaries are chosen, right? So the first six salaries in the table are chosen. When you think about the ease of which we come across those first six salaries, we could say that they are a convenience sample just because we chose them because of the ease to which we have access to them, okay? Now, example C, suppose every fifth salary in the list is chosen. So every fifth, every nth, right? This is a rule. So C would fall under systematic, It's following the rule, every nth individual. And then we have D. D says you write each salary on a card and put all the cards in a hat. You draw 6 salaries without looking. So this sounds like it's pretty random, right? There's no specific order, there's no rule, so this would fall into D, a simple random sample. All right, so now we're going to go ahead and look at example 1. It says identify the population, classify the sampling method, and decide whether there is bias or not, and explain the reasoning. Now, I'm going to go ahead and give you my examples, but as we go through this, think about your reasonings, right? Why would you say it is biased or not biased, and who would you consider to be the population? So, example A says the officials of the NFL want to know how the players feel about some proposed changes to the NFL rules. They decide to ask a sample of 100 players. So if we're looking at the population, well, who is it that they're interested in? They want to know how the players feel, right? So if we want to know how the players feel, who is our population? Our population would be all of the NFL players, right? How do they feel about the rules being imposed on them? Now, for A, the officials choose the first 100 players who volunteer their opinions. Again, look for those keywords, in this case, volunteer. So we know that because of this, this would be a self-selected sample. Okay, now think about this. Is there a bias to this or not? So if you think about the #1 football team in the country, okay, or your favorite team, right, and you have your players volunteer to answer whether they like rules or not, because they're the top team in the country, they would probably say yes, we're okay with following the rules. However, if you look at one of the lower end teams, would they be just as okay with those rules, or are they being forced to follow the rules? So in this case, yes, there is a bias because those that volunteer are probably the ones who have an opinion on the rules that they are being told they have to follow. Okay. Example B says the officials randomly choose 3 or 4 players from each of the 32 teams. That means that each team has an equal representation. Well, again, groups, individuals from each group are selected with a random sample from each group. So this would be a stratified sample. So stratified. Now, is there bias when we are looking at a random sampling from each team? No, there's no bias, right? Because everybody's being given an equal opportunity to express their opinions. And finally, for C, it says the officials have a computer randomly generate a list of 100 players. It doesn't say from the top 10 teams, from the bottom 10 teams, it can come from any single team. So it tells us randomly generates. This would be considered a simple random sample. And when it comes to simple random samples, there is usually no bias involved. Okay. Example B, administrators at your school want to know if students think that more vegetarian items should be added to the menu. So if we're talking about a school and our admin wants to know what students think about the menu items, right? Who is it that eats from the menu? Are they interested in staff? Are they interested in students? Are they interested in everybody? In this case, it is the student population, or better said, every student. Okay. Now, example A says that administrators want to survey every 25th students who enters the cafeteria during lunch. Well, if we're looking at every 25th student, that means we're following rules here. This would be considered a systematic sample. Okay. Now, is there a bias to this? Well, it could go both ways here. We could say no, there's no bias because they're following a rule, right? However, when you look at this example, we're being told that we're only surveying those who enter the cafeteria during lunch. What if you don't have time to go to the cafeteria during lunch and you go after school to pick up something to eat? Or you ask your friend every single day to get something for you, right? Is that being fair? Is that taking into account every single student um, and taking their representation into consideration, right? What if you're one of the last people to enter, right? They're going to survey every 25th student. Are they going to be there the entire lunch? It doesn't specify. So in this case, you could say there is a bias. You could say there's no bias. Personally, I think there is a bias. Oops. Because not everybody, not every student goes to the cafeteria, right? There are carts outside where you could purchase food. You can go off campus to purchase food. That is not taking your opinion into consideration when it comes to talking about the school menu. All right, example B. The administrator surveyed the first 50 students, who get into the cafeteria to buy lunch, okay? Well, if it's the first 50 students, we are looking at this being a convenience sample because it is who they most easily have access to. Now, is there a bias? This kind of goes with what I said about example A. Are they taking into account every single student, every single student who's hungry, every single student who eats from the cafeteria? I would say there is definitely a bias here because you are not looking at every student who eats in the cafeteria. You're just looking at the ones who are the hungriest, right? The ones who arrive first to pick up their lunch. And finally, example C, or part C to this one, the administrators use a randomly generated list of 50 students from a master list of all students. Now, what kind of sample is this? Because it is random, it is a simple random. There were no groupings, so it's not stratifier or cluster, it's just simple random. Is there a bias? Well, when we think about this list being generated from the master list, right, which is the list that includes every single student, there is no bias being imposed here. Because it does not matter if the student takes their own lunch from home or eats in the cafeteria or goes off campus. They are asking the honest and sincere opinion of every single student, or at least those 50 students from the master list of students. All right, once again, hit that pause button. Go ahead and try example C on your own. Think about the population, sampling method, and if there is a bias or no bias, and then come back and check your answers. All right, so if you took a look at C, first of all, when asked for the population, you should note that we are looking at adult residents only. So when you think about drivers, yes, we do have teenage drivers, we do have young drivers, right? But it says they are conducting a survey to find out if adult residents think that the use of handheld cell phones while driving should be banned. So who's our population? Who are we targeting this to? We are targeting it to adult residents only. Okay. Now, for part A, the newspaper sends a text message to a random selection of 1,000 subscribers whose cell phones are listed in the paper's subscription database. If you said simple random for this one, I can see why you would say simple random, right? Because that word is random there. However, we are specifically looking at those cell phone numbers listed in the subscription database. Does everybody have a subscription? No. So this really is a convenience because they have that list in their database of people who subscribe and who are more likely to read the paper and answer this survey. Now, is there a bias? Yes, and I just told you why. Because we are looking at convenience based on those who have a subscription. Not every adult resident has a subscription to a newspaper, so this survey is probably not going to get out to as many people as it should, right? If you said something different, if you believe different, let me know. And for B, using 10 neighborhoods in which the city is decided, or I should say divided, The newspaper randomly contacts 100 adults living in each of the neighborhoods. All right, so this one, going back to cluster and stratified, okay? Why do we know it's cluster or stratified? Because we are looking at divided groups, okay? We're looking at 10 neighborhoods in the city. Now, it tells us that they randomly contact 100 in each of the neighborhoods. That means that each of the neighborhoods has an equal representation or has the opportunity to be represented. That's what makes it stratified. Okay. If it weren't looking at each neighborhood, if it would say that we would contact 100 adults randomly, then it would be cluster. But because each of the groups is being represented, we know it is a stratified sample. And because every neighborhood is being represented, there would be no bias.